want the moment around O as a vector caused by these two forces in this case. If we draw our diagram, we have the origin, our y-axis, our x-axis, our z. Up here I have a point A. I have a rope going from A to B that has a force in it. I have a rope going from A to C that has a force in it. So I want to include that point B, and I want to include that point C. We're in 3D, so coordinates are going to be very helpful for us. So point A is located 6 meters above the origin, so A would have coordinates of 0, 0, 6 meters. Point B is located on the y-axis, and we have to go 2.5 meters from the origin to get there. So 0, 2.5, 0 are the coordinates of B. Coordinates of C is located on the xy plane, so we don't have to go anywhere in the z direction, at least from the origin. So we have to go 2 in the x direction and -3 in the y direction. So this will be at 2, -3, 0. Also in meters. Now, again, why do we want A and B, or B and C? Because we know that a rope goes along that direction. So we're going to be using this to our advantage because we'll know the direction of the force in these ropes. So again, one force that starts at A and points towards B, and we're actually told its magnitude here, 780 newtons. And also a force that starts at A but points towards C. And we're given its magnitude of 420 newtons. This is technically not a free body diagram, or at least not a complete free body diagram, but it is a diagram that's going to give us the information we need to solve what is the moment around this point O. Any questions on the diagram step? All right, so now we have our equation. Again, we want the moment around point O. Yeah, I'll use the long form for this. There's going to be a moment contribution from force FB and also one from FC. So we're going to have a cross product for FB, R cross FB. Again, we want the moment around O, so our position vector will start at O. Force FB emanates from point A, so it's going to go from O to A. We'll also have a moment caused by FC. So we do the same thing. We do the position vector that goes from A to where force C is applied, which in this example is also at A, or also ROA. And we cross it with FC. Right, so both of these forces are accounted for. So we're going to add the effect of FB plus the effect of FC to get the total moment that they cause around point O. We need component form of forces and component form of our position vectors. So I will actually first write ROA, just so we have that in component form. That's just A minus O. Will be 6K meters. FB, we can write, as we have before, its magnitude times its direction. It points from A to B. So I can write that as U hat AB. The magnitude, again, we're told is 780. And we can find the unit vector that points from A to B the same way we've done it in the past when we were talking about 3D particle equilibrium. Right, so this will be 780 times RAB divided by the magnitude of RAB. Okay? So RAB will be the end point minus the start point. So 0 minus 0I, 2.5 minus 0J, and 0 minus 6K. Divide by its magnitude, this would have a magnitude of 6.5. So, or as a separate step, we can just write unit vector AB like we have in the past. I kind of combined a couple things in this example. But 780 times this is going to give us in component form the ijk components of FB. So 780 times 2.5j over 6.5 is going to give us, for force B, 300j. And that will be minus 720k. And this is in newtons. We want to do the same thing for FC. We want to find its ijk components. We know its magnitude is 420. And we have to multiply it by its unit vector, which goes from A to C. So these are different. Even though they're both located at A, they point in different directions. Right, so 420, I won't go through the steps, but we find the unit vector U hat AC. And we can get FC in component form is going to be 120I minus 180J minus 360K, also newtons. Questions on these three steps. So again, I'll reiterate, why are we doing this? To do the cross product, at least with determinants, we need every vector, we need to know its ijk components, which initially we don't. But now we do, because I know ROA is 6K. I now know the ijk components of force B. I know that again. And I know the ijk components of force C. Now I can write this. This is just a long equal sign here. I can now write this first cross product as a determinant. So ijk, 0.006 meters, because that's ROA is just 6K. And FB, down here we know is going to be 0I, 300J, negative 720K newtons. So this is just rewriting this cross product in determinant form. I then add to that cross product, or that determinant, a second determinant. The second row is the same, but now the third row is different. 120, negative 180, negative 360 newtons. So we have, this is R cross FB, R cross FC. We need to expand these now because we want to be able to write MO just as I, J, K. So take a couple of minutes, expand these out, and see what you get as your result for the moment around point O. So if we expand this first determinant out, we're going to have 0, 6, 300, negative 720, I. The J will be 006, negative 720. I guess for kind of as a shortcut, anytime you're going to have a column of zeros or a row of zeros in your determinant, it's going to be 0. So the J, I won't write up here, but if you did, because there's a column of zeros, it's going to go away. For the K, we're going to have the same issue. We have a row of zeros. That's also going to go away. I just won't write it to keep this a little bit shorter. So the J term here, the K term out of this, both of those are 0. If we go over here, if we look at the I do want to write this one down. 0.6, negative 180, negative 360. J, we do want to write down. So minus 0.6, 120, negative 360. J. But if we look at the K, again, we'll have a row of zeros in that 2 by 2, so that's going to drop out to 0 as well. So I'm not going to write it up here, but if you do write it, you'll see that that always drops out to 0. So there's only 3 of them that are non-zero, so that reduces the arithmetic we have to do a little bit. Right, so expanding out this 2 by 2, we'll have a 0 minus 6 times 300. That'll be negative 1800I. 0 minus negative, I think this is 1080, will be a positive 1080I. minus 0 minus 6 times 120 is going to be negative 720. So minus negative 720 will be a plus 720 times j. Questions on getting these three values. Again, the rest of them drop out to 0 anyway, so I didn't write them. But you should be getting 0 for both of the k's and then this j as well. We can add these like terms together. So this is where we get negative 1800 plus 1080 gives us the negative 720i. This is the only j term, so plus 720j. And our units, Newton times meters.